Good morning, ladies and gentlemen. I was asked to talk to you about, the title is The Inner Workings of a Deciduous Fruit Tree. But if you look at the subtitle, it says the phenology of the tree, shoot growth, manipulation of shoot growth, pruning cuts and reserves. Now, this is quite a mouthful. Normally I would take quite a number of lectures at university to cover these topics. And each of those lectures would be at least 50 minutes long. So I'm going to try and fit it into the 45 minutes I've got. I know that is a very long period for people to sit and concentrate and listen to me. So please bear with me. The idea is also to introduce new growers to these topics. So if I talk below your level or above your level, I'm sorry, it is quite a diverse audience that we have here today. So what I'm going to do is firstly discuss the phenology of the tree, then shoot growth, then something on the response to pruning cuts, also introducing some of these for some of the presenters after me, and then very briefly look at reserves. So if we talk about the phenology of the tree, I think to a lot of you the word phenology is probably new. It probably doesn't mean a lot. So let me give you the definition. As it says, it's the study of cyclic and seasonal nature phenomena, especially in relation to climate and plant life, which is still quite a mouthful and probably not that easy to understand. But really what the phenology of the tree refers to is what happens to the tree and when. Okay, so we take a 12-month period and we look at what the tree does over that 12 months in total. So it's going through the different seasons from winter onto spring to summer and autumn, and what are the different processes that take place during that time. Okay, if I summarized it, it becomes a very, very complex graph with lots of different processes. So let me go through it in steps. Firstly, if we take the 12-month period and we start off with full bloom, and I'm using an apple tree as an example, saying that we have full bloom somewhere in October towards November, depending obviously on where we are growing these trees and what cultivar it is, but this is roughly speaking when it happens. Doing that full bloom date we can give that a single date for an orchard, but we know that the bloom period actually stretches over a couple of weeks even, starting and increasing in bloom density and then decreasing towards the end. Okay, I'm still struggling with this little machine here. Okay. Following the bloom period, we'll have a period of fruit set, where the little flowers develop into fruit, and this is an aspect that I will be discussing with you more broadly this afternoon after lunch. And then obviously from that fruit that start to develop, we have a period of fruit growth. And again, depending on the cultivar that we're producing, that fruit growth could be completed in January, if it's an early cultivar, and apples, or run all the way to April, or even early in May. Again, depending on cultivar and also the production area. Okay, and that gives us where the harvest date fits in. Then at the same time we have shoot development taking place as the fruit develop, and we have spurs growing, short shoots as well as long shoots. And these shoots all will stop growing at different times, and we'll look at that a little bit more in detail later on in this lecture. Okay, then also we need root growth, and this is a simplification. I know Dr. Lotze has done a lot of research recently that show that maybe our understanding of when root growth is taking place is not quite correct. But according to the literature, in any case, there's a bit of root growth taking place early on in spring, before actual bud break, during the period from bud swell onwards. And then there's a major peak in root growth really after shoot growth has ceased and also the fruit have been removed from the tree in autumn. So this is the general sort of concepts of when it happens. I know it's not always that simple, and it also depends obviously on your growing conditions as well as the age of your trees. Then we have a period that we call a period of secondary growth. This is the time of the season where the tree actually increases in girth, so your trunk grows, your individual branches and limbs on the tree will increase in thickness. So this also happens at the time, or during the autumn period mostly. And then we have end of leaf drop. Now again, very dependent on the production area. We have a period of leaf drop taking place, but around the beginning of winter, final leaf drop, and then the trees are in dormancy. And again, you'll hear more about that later on. Then we also need flowers for the next season to develop, and in general, we believe that, and if you look at the spur positions, bearing positions on the tree, that flower initiation takes place in about the first week of January. This is work done by Berg in the Elgin area, so based on local research. And the period before that, during the period that the shoots are actually developing, we have a flower induction taking place. This is where the decision is made whether a meristem will become reproductive or whether it will remain vegetative. And then once initiation has taken place, then the flower has to develop and differentiate, form all the different parts, so that there's a complete flower available for full bloom the next season. So we can see that there are a number of processes happening at the same time on the tree, and this is what makes growing apples a lot more complex than growing something like maize. In the case of mealies, we sow the seed, we grow the plant, it flowers, it forms the fruit, and we harvest, and that's the end of the plant. In this case, during the time that we have shoot growth and fruit growth happening, we also have the flowers for the next season starting to develop. And these things influence each other, and if we do not handle the process of, say, shoot growth and fruit growth correctly, we will have a negative impact on flowering for the next season, which means we run into a situation where we get alternate bearing, a high yield followed by a low yield if we don't manage this correctly, but we'll talk about it a little bit more this afternoon. Then there's a period that's also quite important in fruit production, and that's the period just prior to full bloom, where we normally look at the development of the tree in a little bit more detail, and specifically at the flower buds. The process starts off with a dormant bud in winter. Then about 3 weeks, depending again on the area and the climate, about 3 weeks before full bloom, the bud swell will start. And we know that some of the manipulations that we do in orchards, we aim at bud swell. So that's very important to see that difference where there's just a very small increase in size as the buds start to develop in spring. This is followed by green tip. Again, some of the manipulations that we do and applications of fungicides and insecticides, we aim at these different dates, go through green tip onto what we call mouse ear, cutwood. Then it moves on to the closed cluster, and that's followed by the pink stage, and again followed by full bloom, and then the petal drop stage where the individual petals have fallen from the flowers. Okay, so these stages are all part of what we describe as the phenology, and it's very important to note the dates for these different developmental stages, because we quite often use that to make comparisons between seasons and to know whether we've got an earlier season or a later season. But apart from that, we do certain manipulations at these different stages, so it's important to make a note of when your trees are at these different stages. Okay, that brings me to the next part of the presentation, which is about shoot growth. Now, firstly, a new shoot develops from a leaf bud, or we can also call it a vegetative bud. And to know what happens from, or what develops from a bud, and we can look at this shoot on the left here. You see the different buds sitting here on the winter shoot. It will grow out and develop, and we first have to understand what is inside a bud like that, or what does it consist of, to understand why some of these develop into long shoots and some might remain relatively short. So if we look at a bud, normally, and this is just an average for apples, it will contain about 9 to 11 bud scales. These are the scales that are on the outside of the bud, protecting it through winter. And as the bud opens, they will drop off and disappear. You can see them at the bottom here. That's followed by what we call transitional leaves, but they're not very important, so let's forget about them. And then also inside that bud, there are a number of leaves. Okay, so when you look at a tree in winter and look at the individual buds, it will be closed up by the bud scales, but inside there will be a number of foliage leaves or leaves. And normally around 5 to 9, it can be fewer, can be more, but that is what's inside that bud. And then very important, right in the tip of that bud, there's what we a meristem, or a growing tip, which can continue and form more leaves as the bud grows out. So what can develop from a bud? And I'm just now, I know this probably is not a photograph of a leaf bud, but let's assume it is. If we have a bud in any position on the tree, and it is a leaf bud containing those structures that I just mentioned, then the first thing that can happen is it actually remains dormant and dies. Okay, nothing grows from it. Then it can form a little rosette, and these are just where you find a few leaves opening up and sitting in very closely together in a rosette. Then what we normally see is that they can develop into spurs, and I will show you what these look like, or into short shoots or long shoots. Okay, so most trees will have any number of these structures developing in spring. The difference between them, if we look at this example, here we have a little spur containing 9 leaves. This is a short shoot, also containing 9 leaves. And then we've got a long shoot, and I cut it off at one point, but it contains, in this case, 24 leaves. Now, what is important is that the difference between these structures and why they develop. In the case of the spur, we have those 9 leaves without any internode elongation. Okay, so the leaves sit very close together. So you can see there's not much distance between the leaves. In the case of the short shoot, we again have those 9 leaves, and those 9 leaves were present in the bud when it was sitting on the tree in winter. But in this case, the internodes have elongated between the leaves to form the short shoot. Whereas in the case of the long shoot, we have the 9 leaves that were originally present in the bud, with the internodes elongating, exactly the same as in the case of the short shoot. But in addition to that, that growing tip that was inside the bud started forming more leaves. Okay, so it forms a whole bunch, and in this case, as I said, we had 24 minus the 9, so it formed an additional 13 leaves. Sorry, my calculation not quite correct there. So we call these new leaves that are formed, and this happens if the growing point of that shoot is very active. Okay, we talk about plastocrons and all sorts of things, but let's just leave it at that. It's a very active growing point. It will keep on forming new leaves that were not present in the bud during winter. In in the case of the short shoot or the spur, all those leaves were present already inside the bud at the time that it started growing. Now the big question is, why do we get these differences? Why do certain shoots that develop become long shoots and others stay short and become only spurs? Okay, just again to show you what it actually looks like. Down here, that's the length. If you can see my little indication there, that's the length of the internode. In this case, there's the internode elongation giving us the short shoots. Okay, so why the difference in length? Firstly, the thing that is very important is the position of your vegetative bud or your leaf bud on the tree. We see differences in the position, the more dominant positions. The chances are that the shoots will become longer. In the less dominant positions, the shoots will become shorter. So typically, if you have an upright long shoot like this one, the brown section here, if you just leave it, normally we would find that the shoots at the top part of that or the distal part of that shoot will become long shoots, and the further we move down on that shoot, the shorter they will be because they are dominated by the top part of that shoot. Okay, the same thing here. You can see the longer shoots at the top, and as we go down, they become shorter and even stay dormant and not grow out at all. But then also bud quality plays a role. Normally the quality of the buds at the terminal side of a shoot, one shoot in winter, will contain more leaves than the ones further down. So a bud sitting in the positions at the top here would maybe have 9, 10, 11 preformed leaves or leaves present during winter, whereas the buds down here will contain fewer leaves and therefore become shorter shoots. So even if we say both of these are short shoots, the one is slightly longer than the other because it actually contained more leaves during winter already. Okay, so that's also, if you look at something like a rosette forming, it normally would only have 2 or 3 leaves and very small development taking place from there. Okay, I'm not going to spend a lot of time on the end of shoot growth. What we normally see is an active growing shoot like this. Those last leaves will develop into full-size leaves, but all the new little leaves that the bud is, or the meristem is forming, will actually develop into bud scales, and a new bud will form in the terminal position as well as in the axils of these leaves, and those will be the buds that will grow out in the following spring. Just to show you what it looks like, there's the terminal bud forming, fully developed foliage leaves around it, and in that bud, towards the end of the growing season and going into winter, it will exist out of the bud scales plus those preformed leaves that will eventually grow out the next season. Okay, so how do we control shoot growth? I'm just very briefly going to look at this because of the lack of time, but we can use rootstocks. We know that we've got more dwarfing rootstocks available that will lead to less strong root growth, M9 for instance. We can use bending to change the dominant position of the individual leaves or leaf buds. For instance, this is typically what the response of an apple shoot will be when we bend it into different positions. You can see that in this case, compared to the upright shoot, we still got some strong growth at the tip of the shoot, whereas if we bend it to 90 degrees, the most dominant buds are now in a different position, and therefore that is where you will find your stronger shoot growth developing. We can also use techniques like girdling, although I don't believe it's all that successful always in reducing vegetative growth. We can use growth regulators. We basically only have 2 available, Regalis, which is very effective on reducing shoot growth in apples, and coal-tar, which is registered on plums. And then we can use pruning cuts to change the shoot growth. And that brings me to the pruning cuts that we can use. And again, with the lack of time, it's just going to be quite a brief summary of what's available and what we can use. We basically have two types of cuts. The one is the heading cut, topsnit vir die ouens wat Afrikaans is, and the other one is a thinning cut or eidensnit. Okay. Briefly explain to you what we mean by these. If we have a 2-year-old shoots section, okay, this is your 2-year-old wood with 1-year-old wood at the top. Basically, if we cut a part off the 1-year-old shoot, we call that a heading cut. Okay, so it can be, as in this case, cutting away half of the 1-year-old shoot, or you can cut off less or even more. Okay, that would be what we call a heading cut. In the case of a thinning cut, we basically remove the whole of the 1-year-old wood. All of the 1-year-old wood would be, if we cut that away and only leave 2-year-old wood, that would be a thinning cut. Okay, if we quickly look at what happens when we do winter heading in 1-year-old shoots, and just interesting enough, this is a sketch made by a German researcher called Koopman. And you can see way back in 1896 is when he worked on and this is cherry shoots, and looking at the response. And basically, you know, the way the trees responded more than 100 years ago is still the way they respond today. What they did, and I see it's cutting off a little bit at the bottom here, but he looked at the depth of the cut. Okay, in this case, you have a shoot that was left unpruned. In this case, it was just a tiny little bit pruned away there, a little bit deeper, 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 all the way down to quite a severe cut made during winter. And the response is what we see here. Firstly, with a very severe heading cut, we have only one new shoot developing in the place of the shoot that was removed, and it's quite strong growth. The same here. In this case, 2 strong shoot growths, whereas if we remove very little, so you have a less severe heading cut, you find that you get more shoots developing, but the individual shoots grow less. Okay, and whereas unpruned, this is typically the response that we will see. So to summarize, and these are just some of the rules that Koopman wrote, there's a lot more, but more severe heading cuts, you would get stronger growth of the uppermost shoot that develops. Okay, so do a strong cut, you'll get a strong growth in the place of that. The number of shoots that develop would be fewer if you do a more severe cut. If you only tip the shoot very lightly, or you don't do any pruning, you will get more shoots developing. If you do very severe heading, it's dwarfing. So if you would add together, I'll just go back, if you add together what was left at the bottom here, plus what developed on top of that, if you do a very severe cut, the total growth will be less than in the case where you did a very light cut. Okay, adding up all of this growth here is a lot more than on this side. Then normally you would also find that the root growth decreases with severe heading, so you're reducing the growth above ground. That will lead to less growth below ground. And also very important, the more severe you cut and you get these strong shoots developing, you will reduce the flowering, the number of flowers that develop for the following season. So one has to know where you want to use these cuts, because you have to understand the response that you will get. But how you use them, I will leave it to Nigel to explain when it comes to training systems. Okay, so if we compare the result from heading versus thinning cuts of 1-year-old shoots, and I try to draw 2 similar branch systems. In this case, you're removing 50% of all the 1-year-old shoots by heading each one of the shoots, and only leaving 50% of the growth. In this case, you're removing 50% of the growth with a thinning cut, and the response is completely different. In the one case, you get the normal response of what happens when you do a severe or quite severe heading cut. You get 1 or 2 or 3 shoots developing, and they grow relatively strongly, whereas taking away shoots completely, leaving the others uncut, and you're actually removing the same amount of shoots, you get quite the normal response of an unheaded shoot, where you have a number of shoots developing, but the shoot growth is relatively little. So you're increasing the light distribution in the system, whereas here you're causing a very dense system. In this case, you will have a lot of flowers. In this case, you will have very few flowers. Okay, then there are a number of other cuts that are just variations of these, the so-called bunkie or tuppy or toilet seat or whatever you want to call it, where we cut a heavy shoot out in the tree, and it's a heading cut. We are leaving a tiny little piece of the original shoot behind, and the response is getting weak growth developing from that. Maybe better to see here. You can see where the cut was made, and you leave the area where the bud scales were, and you'll get a soft shoot developing from that. It is a type of heading cut, but a very, very severe heading cut, where you take out the too strong growth that you had here. This shoot was too heavy for this leader, and you replace it with something that is very soft. Then I don't think we have many trees that look like this in our industry, but spur pruning is where we would go to very complex spur systems and just cut through them and remove part of it to renew the growth in the remaining parts. Also a system that we don't really use in South Africa is where root pruning takes place. This is where we would actually try to reduce shoot growth by cutting off part of the root system. It's done with an instrument like this, where you stick this into the ground, quite a strong blade on it, and you just rip it through the soil to remove some of the roots. But then you have to know exactly where your roots are, and you have to have a very even distribution of roots to be able to get a predictable result. So not something that we do commonly in South Africa, but it is used elsewhere in the world. Okay, then I mentioned girdling as a way of reducing shoot growth. What we do here, and this is just a schematic representation, we cut through, make a girdle or cut through the bark and the phloem into the cambium of the tree, and I know we actually do cut sometimes into the young xylem as well. This is just to interrupt the communication system within the tree, and one can expect, depending on how big the girdle is that you make, that there might be a reduction in shoot growth. But I know of a number of cases where it is actively used, but without actually reducing shoot growth very effectively. So it is an option. There are different tools that we can use. This is typically what's used in the table grape industry. A knife with 2 blades at a very specific distance apart, which you can use to make a very precise girdle. We sometimes use just scoring in apples, where we make a cut without removing a part of the bark with using the citrus pliers, or we use the chains from the chainsaw, as in this case on Packhams, where quite a wide girdle is made. We have to be careful when we do this, because we are creating a wound, we are interrupting the vascular system of the tree. The wider it is, the longer it takes to heal. I see Ferdi and Vian are recognizing their persimmon trees. This is an example of a very severe girdle that I luckily didn't photograph in South Africa, but in Europe. Okay, I didn't realize the light is so bad on this, because I can see it very clearly. The girdle is in there, and it was made so deep that you can actually see through the tree, and it's 3/4 of the way into the trunk up to that point. So it's only that little bit that's left, And what you see is the response of the tree, that it actually tries to survive by sprouting from below the girdle. So if you do use girdling and you're seeing the tree respond by making shoots below the girdle, you know you're actually really stressing the tree. And this is just an example of scoring, but also not that clear. And as I said before, the response that we get on these, I think the best reaction is in terms of flowering. Again, not so clear on this photograph, but this tree definitely has fewer flowers than this one, and this one was girdled during the flower induction phase, and the response of those pear trees are to form more flowers in response to that scoring. Okay, and then to get to the last and final part of my presentation, I was asked to briefly talk about reserves. Now, if we look at our fruit trees, they call deciduous fruit trees, or bladwisselende vruchtebome, meaning that they lose their leaves at a certain time of the year, but they're obviously still alive during that phase. There is some root growth taking place, as we know. There are flower buds developing, and for that the tree needs nutrients. So it has to prepare for that leafless period by storing reserves, much as we do. We try not to, but we sometimes do. Store reserves for times where food might be scarce. What is important is that the leaves are there to produce photosynthates or carbohydrates, and they are also important in the uptake of minerals from the soil and creating the transpiration stream. So while the leaves are on the tree, we have to prepare the tree for that period that it doesn't have any leaves, and but it is still actively growing and respiring and needs these components. So the probably two most important reserves that the tree stores would be carbohydrates and nitrogen. I'm not going to talk a lot about nitrogen at this point because it would take too long, but we do have to prepare that or produce enough carbohydrates to maintain the carbohydrate status of the tree during winter. When we talk about carbohydrates, it's basically starch and sugar and different forms of sugar, but that's what it's all about. So if we look at what typically happens, and I know this is maybe a little bit complex, but if we look at the top graph, the one with the little triangles, we'll see that the starch levels in the tree, and this is looking at all the starch that's in the whole of the tree, okay, the whole tree structure. The starch decreases during winter. It keeps on decreasing. This is bud break, and this is looking at a peach tree, so bud break on the 9th of September. It keeps on decreasing until about 8 to 9 weeks after bud break. Then it starts, and forget about that little blip there, it starts to increase again through the point where shoot growth stops, where the harvest takes place, where leaf drop starts, all the way until the last leaf is dropped, and then it starts to decrease again in the permanent structure of the tree. Now, this is very important because if you look at this phase here, we can see that there's a flattening off of that line, which means that as more and more leaves are dropping, the buildup of starch slows down because the leaves are the factory where the starch is being produced. Okay, and very important, even though this is where bud break takes place at the beginning of September and the new leaves are busy forming on the tree is still using reserves. Okay, this is because the new leaves are sitting on young shoots that are busy actively growing, and they are producing carbohydrates. They are photosynthesizing and producing carbohydrates and sugars, but that is being used by the new shoots that are busy growing. So the tree still cannot actually produce enough carbohydrates to maintain the growth and development that's taking place. Because you've got to remember, at this time when shoot growth is starting, also the young fruitlets are growing. Okay, so you've got fruit that need to grow to maturity. In this case, we're going to pick them by mid-March. And those fruit does not photosynthesize, or very little. So they're dependent on the leaves to supply them with carbohydrates or sugars for their growth. But because the leaves are still looking after themselves in the beginning of the season, because the shoots are growing, it's not producing enough to supply the fruit as well. And at that point, it's still using the stored starch that the tree produced the previous year. Okay, so you can imagine that if I did not store enough carbohydrates in the previous year, then I will have a problem with my fruit growth the next season, because the leaves cannot supply enough carbohydrates yet at that point, but the fruitlets are needing carbohydrates to grow. Okay, so this is the process, and I'm not going to spend time talking about photosynthesis. You're going to have a talk on management of light and why light is important just after me by Michael. But basically, we are farming with light. We need sunshine for photosynthesis to take place. Okay, photosynthesis is the process that produces these carbohydrates, and we need the light on the leaves for this to be able to happen. So if we want to manage how many reserves are produced by the tree, then we have to manage light and leaves. Okay, the leaves are the factory, the light is needed for photosynthesis to take place, as well as CO2 and water. So firstly, the way that we manage reserves and make sure that we end up, and I'm going to rush back to this slide, we want to be in a position where that starch reserves are at the highest possible level. Now you can see it stops forming when the last leaf drops. Okay, so if we don't have leaves, we can't get starch to build up. So one of the important aspects is to maintain leaves on the tree as long as possible and have them in a fit state where they can produce carbohydrates. Okay, so very important is to look at light interception of the trees, but especially light distribution in the tree. It's no use having a lot of leaves on your tree and they're not exposed to light because the trees are too dense. And again, Nigel will talk about planting systems and how we manage them. But we're basically aiming at making sure that a lot of light actually is received by the leaves so that they can optimally photosynthesize. So your training systems, your row orientation, everything is aimed at making sure that we have light on the leaves in the tree. And another way of getting there is by using the correct pruning cuts at the right time. And we can use summer pruning. If the trees are very dense, we can, with thinning cuts, remove some shoots to increase the penetration of light into the canopy. But we have to be careful not to do too severe a pruning because you don't want to make your factory too small. Okay, so there's a balance as to allowing light into the tree, but without making the number of leaves that remain too little. Okay, then it is very important that those leaves are healthy. For photosynthesis to take place, the leaves need to be green. So we know that as the autumn progresses, the leaves become yellow. But if we use nitrogen fertilizer judiciously, we can keep those leaves green for longer. We also use plant protection to maintain healthy leaves, so make sure we don't get the rooi spinnekop or whatever the case might be, that will make the leaves drop earlier. Because remember, as soon as the leaves are gone, the tree stops photosynthesizing and the reserves are being used for whatever is happening in the tree at that time. So we want to keep the leaves there as healthy and as long as possible, obviously not going into winter too far, but we want to maintain the leaves in a good condition. So very important is to look after the orchard in autumn. Once you've harvested the fruit, no, the fruit is gone, but that doesn't mean you can let go and let the orchard over to itself. It's important to continue with post-harvest fertilization, especially nitrogen. Look after, make sure that your irrigation scheduling is up to speed. try and prevent weed development. You don't want the weeds to use all the water and fertilizer that you're trying to give to the tree. So it's also in terms of irrigation, it's important for the leaves to stay turgid. So we want the stomata to be open for gas exchange to take place, otherwise photosynthesis will not happen. And then also fruit thinning is one way of optimizing reserves by leaving too many fruit on the tree, apart from the fact that they will be too small. We will also have a situation where those additional fruit will be using a lot of the reserves. Okay, so if we do optimal fertilization in autumn, we should have a slightly later leaf drop. And because of the higher reserve status in the tree, we will normally find earlier and faster bud break in spring, so less problems with delayed foliation. A more concentrated bloom, so the blooming period will be shorter. This should result in better fruit set and higher yield, and also better shoot growth, because remember, all of that early development in spring takes place on the reserves that the tree had formed up to that point that the last leaf had dropped the previous season. Okay, so a very important phase of the tree's development is the autumn period, where reserve buildup takes place to support the early growth of the tree in spring. Okay, I think I've run out of time. Not 2 minutes. Okay, well, I'll leave it at that. My timing is not as good as I thought it was, but thank you for your attention.